Alright, you are welcome to this lesson, and in this video we have been asked to check if this function sin 1 over x is continuous at x equals to 0. Thank you for being here. So the first thing we do here is that we check if our f of a is defined. So and we know that this equals 0 and equals to a. So first we check our f of a. Is it defined? Defined. Let us check that. Now f of 0 is equal to sine of 1 all over 0, which is not defined. This is obviously not defined. 1 all over 0 is undefined. So this will give us defined. It is asked, is it defined? No, it is undefined. So 2 says that the limit as x approaches a from the right of f of x must equal the limit as x approaches a from the right of f of x. Now let us check the limit from both sides. Now you notice that as x approaches 0 here, this man you are seeing here approaches negative infinity and positive infinity. You ask me how? Yes, I will say that again. As x approaches 0 here, this 1 over x here, obviously we approach I value and negatively I value. So let's find that. So you have limit as x approaches 0 from the left of 0 of sine of 1 all over x is equal to, now this is our number line, right? This is 0. Any number to the left of 0 is obviously negative. So we have sine of 1 all over negative 0.01. Let's pick that. Now negative 1 all over negative 0.01, we obviously approach negative infinity, and trust me, this man will always approach negative infinity. So as we do this again, the limit as x approaches 0 from the right of sine of 1 all over x is equal to sine of 1 all over 0.01. This also will approach positive infinity, negative infinity. I mean 1 all over this. So we can say that the limit of this function at least does not exist because it keeps on oscillating. How? What I mean is this. You know that this man you are seeing here as 0, as x approaches 0, this man you are seeing here approaches negative and positive infinity. This is because sine of whatever value you have will oscillate between 1 and negative 1. So as x approaches 0, 1 over x approaches negative infinity and positive infinity, which means that this limit does not converge to a single value. So we can say that this limit you are seeing here does not equal f of a, which says that this function is discontinuous at f of a, and this is called oscillating discontinuity because the limit you are seeing here does not settle to a single value. As x approaches 0, 1 over x itself, we approach a very, very high value and a very, very negatively low value, because when you divide a very, very large number by an extremely low number, you get a very, very high number. Thank you and see you. Sorry, before I can say that the limit as x approaches a of f of x does not equal f of a. So this limit is discontinuous and it is called oscillating discontinuity. Thank you and see you in the next video.